Okay, here's the 7-7 part 1 solutions to that worksheet circuit activity. So let's start with number 1. So we need to solve for y. So step 1 with the differential equation, we're going to use separation of variables, which means we get all the y's on one side and all the t's, in this case it's a t, all the t's on the other side. So we have dy dt equals 2t. So I'm going to multiply by dt on both sides. Get it like that. And that's all I have to do here. We've got no other y's, so it's just dy on this side and all t's and dt's on that side. And then after we do that, we can integrate both sides. This one is just going to be y, and then it's going to be t squared, and then it's going to be 2 divided by 2, so that's just 1 plus c. So that's our solution. It's a general solution because we have a C. It's not a particular solution. So once we get that, you had to find at the top of each square, there's a possible answer. So the one that matches up with that is this one, t squared plus 8. Because t squared plus c would just be 8 for this to be the answer. Then we do this one. Again, all we need to do is multiply by dt on both sides, and then we can integrate. It's just going to get us y again. This will get us 1/2 t plus c. And that's all there is to this one. So match that up with a possible answer. That will bring us to this one, 1/2 t plus 7. C is just 7 in this case. So again, we do the same thing. Just need to multiply by dt on both sides. Then we integrate. So this will just give us y. This will give us 1/2 t squared, and then we divide by 2. So that 1/2 divided by 2 is 1/4 plus c. And that brings us to this one here, 1/4 t squared minus 2. C would just be -2. And once again, we're doing that same thing where we just have to multiply by dt on both sides. I probably should have been writing the numbers because that's what the direction said. So let's go back and do that. So number 1 was number 1. This is number 2. Next one, number 3. And this one that we're on now is number 4. Sorry about that. So this is number 4. All right, so we multiplied by dt on both sides. We've got all the t's and dt's over here. No y's, just dy over here. Now we can integrate. This will just leave us with y, and this will leave us with 1/3 t cubed plus c. And then that brings us to our next one here, where c would just be -4. So this is number 5. So this one has a little more to it. So it says solve for y. Sometimes you'll need to factor to help separate. So they factored it for us. So this right here, the dy dt equals 2ty minus 8t. That's the original. And then they factored out a 2t. So this is just dy, just to rewrite it. Dy dt equals 2t y minus 4. Because now we have a factor that has just a t in it. And this factor just has y, no t's. So what that means is that I'm going to divide by y minus 4 to get that on this side, dy. And I'm also going to multiply by dt on both sides to get 2t dt. And that's why it's helpful to factor it like this, to have one factor with one variable and another factor with another variable. So again, just to repeat what I did here, I divided by y minus 4 on both sides to get 1 over y minus 4. And then I multiplied by dt on both sides to get this dt over here. Now I can integrate that. So 1 over y minus 4 dy equals the integral of 2t dt. So this right here, this integral is the natural log of y minus 4 equals t squared, and then it's 2 divided by 2, which is just 1, plus c. In order to get the y alone, we need to do this. That way, the e and the natural log will cancel out, and we're just left with y minus 4. You can get rid of the absolute value once you do that, because it has to be positive. So e to the t squared plus c. So what happens with this c? Well, that comes down in front of the e. The reason for that is that this right here is equal to, so this would technically be equal to e to the t squared times e to the c. If we're using, that is not what it's supposed to be. So e to the t squared times e to the c power. If we're using exponent rules, so if you're adding the exponents, it's the same thing as multiplying with the same base. So e to the t squared times e to the c. Now, since c is an arbitrary constant, e to the c itself, you can just call c. So that's where this c comes from right here. So that comes from right here because c is just a constant, e is a constant, so e to the c is just some other constant c. And that's where that c comes from. Okay, back to blue. So then we just add 4 to both sides, and we have y equals c e to the t squared plus 4. And that's it for that one. One more side note I want to make about this one. If you were wondering how I got natural log of y minus 4, I'm going to do that off to the side up here. So if we have the integral of 1 over y minus 4 dy, let u equal y minus 4 du is dy, and then you're left with the integral of 1 over u du, which is natural log of the absolute value of u, which is where this comes from. So that's kind of a lot, just a couple side notes to make a little more sense of that. All right, so that brings us now to this one. We have 3e to the t squared plus 4. So in this case, we had c e to the t squared plus 4. C would just be 3 here. So this is now number 6. So number 6, we solve for y. So again, we're going to multiply by dt on both sides. But now we have a problem. We have a y and a dt, not a t and a dt. So I'm going to divide by y on both sides. So now I have 1 over y dy equals 2 dt. And then we can integrate both sides. On the left-hand side, we'll have the natural log, the absolute value of y, equals 2t plus c. And then to get the y alone, we do e to the natural log of y power. So then we're just left with y equals, and again, this c comes down in front. Just to really drive home that point I made earlier, the reason for that is because this is the same thing as e to the 2t times e to the c and e to the c itself is a constant. So we still just call it c because it's some arbitrary constant. And that is it. So now we need to find a function that matches up with that. Which brings us to this one, where c is 5. So now I think we're on number 7 now. Yeah, we're on number 7. So again, we'll multiply by dt on both sides. So dy equals 2 dt. And then we can integrate both sides. And this just leaves us with y equals 2t plus c. That was kind of a quick one. And that will bring us to this, 2t minus 5. So c would be negative 5. And we are on number 8. For this one, what I'll actually do, you can think about this like cross multiplying. So I'm going to cross multiply here, and I'll have y dy equals 3t dt. And I can integrate both sides. I'll have 1/2 y squared equals 3t squared divided by 2 plus c. And then to get y alone, I'm going to multiply by 2 on both sides. And I'll have y squared equals 3t squared. And technically this is 2c, but again, it's just an arbitrary constant, so we can just write c again. And then y equals plus or minus the square root of 3t squared plus c. So we write plus or minus unless we have a particular solution that tells us which one it is. Obviously, we don't have a particular solution here. These are just general solutions because we have a c. So we leave the plus or minus. So now we need to find a function that could be y. So the next one, this one right here, so this one is minus, and c is 9. So now we're on number 9. I'm going to cross multiply again because we've got y and dy, and then 3t plus 1 in dt. So y dy equals 3t plus 1 dt. And then we integrate both sides. Y dy will become 1/2 y squared. 3t is going to be 3 divided by 2t squared. And then 1 is just t plus c. And again, I'm going to multiply by 2 on both sides to start to get the y alone. So then I'm left with 3t squared plus 2t, technically 2c, but again, it's just an arbitrary constant, so you can just write c. Then we take the square root of both sides to get y alone, plus or minus square root of 3t squared plus 2t plus c. And then we find a solution that matches up with that, and that brings us to this one. So c is 1, and it's the negative. And now we're on number 10. So for this one, this looks a little complicated, but then once you start trying to factor things out of it, it's not too crazy. So dy dt equals, first thing I'm going to do is factor a y out of the numerator because both of those terms have a y. And look at what happens. You can just get rid of those y's, and that actually makes life a lot easier. So now I'll multiply by t on both sides. So we have dy, and I'm multiplying by t on both sides. So dy equals 3t squared plus 3t. It's just over 1 because we canceled out that y, dt. And now we can integrate. And when we do that, we're just left with y on the left-hand side. On the right-hand side, we have t cubed, add 1 to the exponent, and then it's going to be 3 divided by 3, which is just 1, plus 3t t squared divided by 2 plus c. And then we find an answer that matches up with that, and that brings us to this one here. C is 1/2. So we're now on number 11. So this one, I'm going to cross multiply again. Then we have y dy equals negative 3t dt. So then we integrate y dy equals the integral of 3t dt. This gives us 1/2 y squared equals negative 3t squared over 2 plus c. And then again, I want to get the y alone, so I'll multiply by 2 on both sides, and then I'm left with y squared equals negative 3t squared plus 2 times c, but we just write c because it's just an arbitrary constant. Then we take the square root of both sides. So plus or minus. I don't like to have a negative in the front when I'm under a square root just because I think it looks weird. So I'm going to write c minus 3t squared. Not wrong. If you do negative 3t squared plus c, it's just a personal preference of mine. So then we find a solution that matches that. And here we go. So c is 9 minus 3t squared. And I think this is the last one, if I am not mistaken. Yeah, this is the last one. So, all right, here's what we're going to do. Let's do this in 2 steps. So first we'll multiply by dt on both sides. 2ty dt. But now our problem is that we have both a t and a y. So I'm going to divide by y on both sides. So I have 1 over y dy equals 2t dt. So now all my y's are on one side, all my t's are on the other side. And then I can integrate. So the integral of 1 over y dy equals the integral of 2t dt. So integral of 1 over y is natural log of the absolute value of y equals 2t squared divided by 2, so it's just 1t squared, plus c. To get the y alone, we do this nice little trick. So then we're just left with y equals, I'm not going to write this out again. You know now that the c comes out in front, e to the t squared. And that is it for that one, which magically brings us back to number 1. Because the answer is 19 e to the t squared, so c would be 19. And that is it.